Yeah, friends, welcome to part 7 of our lecture, Becoming a LEED Green Associate. Here, we will be talking about water efficiency. Let's go. Under the water efficiency category, two major strategies are key. One is indoor water use reduction, and secondly, outdoor water use reduction. For water efficiency, if you recall, at the beginning of our lectures, we have said only 3% of the Earth's water is fresh. Therefore, the water efficiency and conservation are important strategies. While water efficiency focuses on reducing potable water usage and increasing non-potable water usage efficiency. This will help in controlling demand, thereby addressing the challenge of depletion of available water resources. So, sustainable measures that facilitate the benefits of the triple bottom line are, covered under the water efficiency category. Like I mentioned, indoor water use, likewise, outdoor water use. The use of efficient plumbing fixtures that consume less water is the focus of reducing indoor water use consumption. Less water than the regular fixtures. To reduce the use of potable water for water fixtures, or to identify alternative water sources that can substitute for the use of potable water. This is key under the strategy for reducing indoor water use. And in doing that, there are 3 approaches for improving this water efficiency. One, like we mentioned, is to install efficient plumbing fixtures. Obviously consume less water and still deliver the intention. Secondly is to reduce potable water use. Where you must use water, then avoid using potable water, or what you want to call fresh water. And number 3 is to track water consumption. That's through the use of meters. The triple bottom line benefits of improving water efficiency is that as water usage is minimized, we're able to maintain water levels sustainably. And by so doing, you also have a synergy in the fact that you are decreasing the energy that is required to manage water resources. Economically, is to lower water conveyance and supply costs. Like I mentioned, you have reduced the energy required for sustainability. By so doing, you have limited the greenhouse gas emissions. Economically, you have reduced supply costs because you have implemented cost-friendly solutions. And socially, you promote environmental well-being and then preserve the existing natural. Now, in installing efficient plumbing fixtures, efficiency has to be the key word, because efficiency is not just to reduce, In reducing the volume of water consumed, you must ensure that you have not compromised the need for water in the first place. So the need is still being met, but the loss is substantially reduced. One can significantly reduce indoor water consumption by choosing efficient fixtures that will still function optimally. They will consume less water than conventional fixtures and even less water than specified in the water sense labels. Now, these are reference standards or recognized tags that you must take note of. The water sense label and the Energy Policy Act of 1992. So you need to pay attention to the reference standards that guide the compliance approach to defined strategies, and in this case, the water sense guiding the approach to the compliance with installing efficient plumbing fixtures. Now, what's the water sense? In establishing and guaranteeing optimal performance, the U.S. Environmental Protection Agency created this instrument called water sense label that would endorse or recognize fixtures that can be called efficient. So for all newly installed fixtures, LEED expects project teams to choose water sense products. Now, water sense labels are available for the following fixture categories: water closets, that is the toilets that have tanks where water is stored. Now, urinals that use water, private lavatory faucets, and shower heads. Now, water sense label is not applicable to the following: urinals that are tankless, compositing toilets, waterless urinals, and public lavatory faucets. So you need to pay attention to this. You will likely come across it in your LEED Green Associate examination. Now, this is an illustration of where you most likely find the water sense label, or how that fixtures are tagged for stakeholders to be able to identify the efficient fixtures to be deployed for their project. So this is the water sense label for products that have been independently certified to meet the EPA water sense criteria. So the water sense certification includes any recently installed or newly installed aerators or flow restrictors that have been, added to private lavatories or showers, meaning even if it's an old building, the fact that there are new installations that fall into these categories, they are eligible or expected to have the water sense certification for considerations to be made for LEED certification. Well, baseline water consumption of fixtures and fittings, I'll be mentioning that right now, and I'd like you to pay attention because these are popular questions in the examination. Now you need to understand the units of measurement: GPF, gallon per flush. And so for WC, The baseline is 1.6 gallons per flush, while 1.0 gallon per flush is for urinal. We also have GPM, which means gallon per minute. So public faucet with the baseline 0.5 gallon per minute, while private faucet as well as kitchen faucet is 2.2 gallon per minute. Shower heads 2.5 gallon per minute. Now other unit you should take note of is LPF, which means liters per flush, PSI, which is pounds per square inch, and kPa, which means kilopascals, and of course liters per minute with the acronym LPM. Now, what are high efficiency toilets? Now, you need to understand that traditional toilets that we have been used to, like I mentioned, typically consume 1.6 gallon per flush. But the high efficiency toilets consume less than that. In fact, they may just need 1.28 gallon per flush, which results in about 20% reduction. Some even consume as little as 1.1 gallons per flush. From innovation. So to be considered a water sense high efficiency toilet, the toilet must comply with strict efficiency and performance criteria as determined by an independent testing laboratory. The water sense label can only be applied after this top 30 certification has been passed. So you need to understand this. This is the process high efficiency fixtures or toilets go through to get the water sense label issued. Right now there are 12 flush toilets. They use two buttons to release different quantity or volume of water depending on the intended use. This helps to save both the water and money. The full flush option uses between 1.28 gallon per flush to the baseline 1.6 gallon per flush, whereas the half option would naturally need just barely 1.0 gallon per flush. The waterless urinals have emerged as a smart water-free solution that can reduce cost and save water. Now, they don't only benefit the environment, but studies have also shown that they can improve hygiene and sanitation. So many problems such as odor, because they do not require flushing, and flooding are eliminated. Of course, this also has impact on reduction of the cost of maintaining sewer facilities. So it's an innovation, the waterless urinal. Number 5, we have the composite waterless toilets. These are dry toilets that use aerobic processing system to process waste from humans. And this is another viable alternative to conventional flush toilets. They require minimum water usage, and the process of the use of this composite for the toilet, as explained here, results in odorless operation and complete decomposition of the waste. And there are 3 separate processes that your composite toilet is expected to perform. The compost as well as the toilet paper should be composted without any odor. The resulting compost is expected to be safe and simple to manage because the liquid component should have been evaporated. So this is as far as the composite toilets go. You may be asked this question if they are suitable for multi-story structures. They are not. They have not been found to be suitable for multi-story structures. You may also want to read more about water efficient shower heads, where the water source label ensures that shower heads do not use more than 2 gallons per minute as against the baseline 2.5 gallons of water per minute. Also have water efficient faucet and faucet accessories with the expectations in terms of by the use of aerators be able to restrict water flow to a maximum of 1.5 gallons per minute as against the conventional flow of 2.2 gallons per minute. And you have the pre-rinse spray valves usually used in commercial and institutional kitchens to eliminate food waste from dishes before washing. So this will actually reduce water waste during. We have a clip here that shows how the pre-rinse valve actually works. So it's an addition to the water use reduction strategy. Okay, reducing potable water use. The immense amount of water wastage can be cut by implementing a water management plan and considering the various water systems right from the design stage. Incorporating, don't forget what we said about the iterative process and the expectation. Incorporating alternative water sources and engaging efficient appliances and fixtures, significantly reducing water usage. Water system design. Conduct research into potential project opportunities that apply those conservation methods and explore how you can integrate all these systems for optimal results towards achieving your reduction of potable water use. Then it's important to establish water levels and goals and targets which will guide the system design, and then develop or determine appropriate strategies and coordinate technical meetings to discuss those strategies and possible alternatives. And then the systems that align with all of these goals already established can be developed to facilitate conservation of potable water. Now, as part of the alternatives, processed water can be used in the place of potable water. This may include rainwater, condensate, possibly for your air conditioner units, or the discharge water. But if it is grey water, it may require treatment because of the chlorides that are already dissolved in it. So there should be a test for the concentration level of the chlorides to ensure that the assessed concentration level is within the acceptable standards before using that grey water. There's also the opportunity to use rainwater, you know, involving collecting water from impervious surfaces like rooftops, patches, driveways, pavements, and all. So the buildings and landscape can be purposefully designed to take advantage of the amount of water collected. And this goes a long way to offer affordable, you know, and sustainable solutions to reducing the use of potable water. This is important for you to take note of. Then tracking water consumption. This is primarily about installing meters. Uh, Measuring water usage is an effective approach to establishing independent system baselines. You're able to compare the actual usage of the design against what was the uh, standard case of the baseline or the ideal case. This also gives the managers the opportunity to detect and identify possible wastage channels and block those channels. So that's the importance of having permanently installed meters to measure potable water. Now, the outdoor water use. This is all about selecting water conscious plants and vegetation. We mentioned this on the sustainable side. Also, designing landscapes that minimize water usage or employing alternative water sources besides the use of potable water. Using efficient irrigation methods and also periodically monitoring the water consumption. Now, I mentioned the strategies for outdoor water use efficiency. 1, a water efficient landscape design. 2, efficient irrigation techniques. 3, decrease in the consumption of potable water. And 4, like we just mentioned, monitoring and tracking water usage. The triple bottom line benefits cannot be overemphasized. Cost-effective solutions reduce the expenses associated with supplying potable water. Environmental well-being is enhanced, and then the natural hydrology is also preserved. In achieving the outdoor water use reduction, there are strategies such as the landscape design, using strategies like mulching, native plant species, capturing rainwater, avoiding invasive plants, all being noted right from the pre-design phase. Secondly, we can achieve this by choosing appropriate plants or using xeriscaping, which promotes sustainable design and water conservation by reducing or eliminating additional irrigation. Now, that is a concept of zero-scaping or xeriscaping. It's a cost-effective alternative with additional maintenance, and it's a sustainable response to how we can pay attention to the maintenance of our landscape without depleting the freshwater resources. We talked about mulching earlier. This is just about adding a layer of material to a specific surface to enhance its productivity. The benefits are listed on this slide, number 22, and it will be good for you to familiarize yourself with what they are. Now, we also have reduce tough grass. Now, conventional tough grass lawns need significant maintenance, they need irrigation, and they need fertilization. This can be expensive, and also it has negative or adverse effects on the environment. So LEED recommends that tough grass with ground cover, uh, tough grass be replaced with ground cover or indigenous grasses, which will require less water and of course maintenance, because they are familiar with the terrain and they are grown to survive such difficult terrains. So this is the concept for reducing tough grass. Also, we talk about the use of efficient irrigation strategies. Drip irrigation, which is a water-saving method. This delivers water directly to the soil or to the plant roots via tubing. This makes water easy to conserve and can contribute to irrigation credit for water efficiency. Also, making it ideal for drought-prone areas. This reduces the heat island effect and promotes sustainability, even though there may be some slight higher cost at the beginning. Secondly, WBICS is weather-based irrigation controllers. These respond to real-time weather data to adjust watering schedules based on watering needs. Of course, by so doing, water consumption is reduced. So this technology uses on-site sensors and signal-based control. This goes a long way in helping to save more water. Okay, we also have landscape efficient operations and maintenance. These are recommended measures to be taken during this stage of the building use to ensure sustainable turf maintenance. Deeply water the entire root zone. Avoid under or overwatering by utilizing smart watering techniques. Schedule the irrigation based on the minimum requirements for the plant health. Adjust the irrigation schedules based on seasonal differences or seasonal changes. Regularly inspect the irrigation systems for any malfunctions that could have been leading to wastages or leaks. Also, regular training sessions for the maintenance staff and users on proper landscape maintenance techniques. Reducing potable water use. Irrigation can utilize non-potable water as a substitute for potable water. Rainwater and grey water are acceptable options in this regard, as they do not contain organic compounds. However, black water, which is grey in terms of the pronunciation GRAY, which does contain organic substances, like we mentioned, dissolved chloride, is prohibited from use in irrigation for most locations. In instances where it is allowed to be used, there's a measure of acceptable concentration level for dissolved fluoride that must be tested for in the water. So one way is to use rainwater or grey water. And number 4, for tracking water consumption, LEED expects that the amount of water consumed should be recorded, as this is a crucial aspect of determining the quantity of water utilized in the course of operating the building and how much has been saved. So it is a case of what you cannot measure, you cannot manage. So it is mandated by LEED to evaluate the fixtures utilized and make modifications accordingly. The results are to be shared with USGBC to provide historical data from actual projects that can help other projects. Again, installation of meters, crucial for identifying areas for improvement and preventing potential leakage or overconsumption. And finally, as we wrap up this chapter, we'll talk about water audits, which is a platform to help the project teams to manage water systems effectively by checking usage, identifying leaks, and generally improving the performance. This process involves analyzing factors such as supply, consumption, the losses along the line, meter accuracy or integrity, operational efficiency, and financial indicators. This gives the managers essential data to reduce consumption and to optimize water usage. In the next part of our lectures, we'll be looking at energy and atmosphere. I'll see you there. Right.